Hey guys, today we're going to be doing the Boots multiplication. And before we get on to this topic, we need to know two basic things, which are the right shift circulant or RSC and the right shift arithmetic or RSA. So what is the right shift circulant? It's basically moving binary numbers in a circle. So just imagine you have the number 11011 and you want to make a right shift circulant out of this. So what do? All you just need to do is make a circle. You bring the last bit and take it here to ensure it's the first bit. That is all you need to do. But remember, initially we had 5 numbers. So in order to make this circle complete, we also need to have 5 numbers at the end of this problem. So basically, all you need to do is, like I said, bring this 1 up to the front, which will be 1 1 1 0 1. We have 5 numbers now. So what happened to this last one? You're basically going to cancel it because that number has gone to the front. So that's why it is a circle. So that's why it's a circle. It's like a circular process. So let's have another example. Let's say we have 0 0 1 1 1 and you want to make the right shift circulant out of this. So like I said, all you need to do is take this number to the front and fix the remaining 4 binary numbers. So it's going to be 1 0 0 1 1. So let's say we want to make the right shift circulant out of this number again. All you need to do is bring this 1 to the front again and take all these numbers along with you. So your final answer is going to be 1. Then bring all of this here. 1 0 0 1. And let's say we want to do it again. Like I said, all you need to do is bring this 1 to the front here and take all these numbers along with you. So your next answer is going to be 1, then this 1 1 0 0. And let's say we want to make a right shift circle out of this again. What do? Like I said, you bring the 0 up front and take all the remaining numbers along with you. So it's going to be 0 and take all these numbers with you. 1 1 1 0. So the second concept you need to learn is the right shift arithmetic. So just imagine you have a number 11011 and you want to make the right shift arithmetic out of this number. What do? All you just need to do is you make a copy of it and then you shift the remaining bits to the right. So like I said, the answer is going to be a copy of this first bit. So it's 1 1 and then you just shift this to the right. So you just continue with this 1 0 1 1. That's your answer. So what's going to happen if your very first bit is 0 1 1 0 1 0? What do? Exactly, you do the same thing. You make a copy of this bit and then this is going to follow. So what's the answer to this? 0 0 and this follows 1 1 0 1 0. So that's all you need to know before you start doing the Boots multiplication. So right now we're going to do the Boole's multiplication. Let's say we're given this problem 1101 times 1011, and we're asked to use the Boole's multiplication in order to find the answer. The first thing you need to know is how to allocate your x's and y's. You want your x's to be the least number of switches between ones and zeros. What do I mean by that? From 1 to 0 is one switch, right? So let's use this example. 1 to 0 is one switch, 0 to 1 is another switch. So in total you have two switches. 1 to 1 is the same thing, so there's no switch between the ones and zeros. So here we have two switches. And for here, 1 to 0 is one switch, and 0 to 1 is two switch. 1 to 1 is the same thing, so we have like two switches down here also. So let's say we are given like a problem in which it's like 1 0 1 1 1 times 1 0 1 0 1 0. And let's do the same thing. From 1 to 0 is one switch, and from 0 to 1 we have two switches in total. From 1 to 0 we have one switch. From 0 to 1 we have two switches. From 1 to 0 we have three switch. From 0 to 1 we have four switch, and from 1 to 0 we have five switch. So in this kind of example, your x is going to be 1 0 1 1, and your y is going to be 1 0 1 0 1 0. We can pick any one of these two to be your x and or your y, because like they have the same number of switches between them. So right now we'll just say our x is equal to 1 1 0 1, and our y is equal to 1 0 1 1. We need to get the 2's complement of y, because we might do addition and subtraction in this multiplication problem, and instead of like doing the subtraction in binary number, it's easier to just get the 2's complement of y and just add x to that 2's complement. This might be really hard to understand right now, but during the course of this video you will understand what I'm trying to say. So in order to find the 2's complement of negative y, I'm going to quickly remind you. Let's say now we know our y is 1 0 1 1, and you want to get the 2's complement. I'll just shorten it and say the 2c. We're just going to flip this number. So 1 if you flip it is 0, 0 if you flip it is 1, and 1 if you flip it is 0, and if you flip 1 again it's going to be 0, and you just add 1 to the end. So that is 0 1 0 1. So that's how you get your 2's complement. So right now this result is what we're going to place right here, and it's going to be 0 1 0 1. It has to be the 2's complement of y. So right now we're going to make a table. You're going to have u, you're going to have v, you're going to have x, and we're going to have x minus 1. So we're going to make a table out of this. Your u's and v's always start with zeros. So here you see we have 4-bit numbers, 1 1 2 3 4. So that means you'll use the number of zeros is going to be 4. 1 2 3 4. And same thing goes to your v, 1 2 3 4. And for your x, all you just need to do is copy down this x and put it here. So it's going to be 1 1 0 1. Your x minus 1 always starts with 0. Always start with 0. This is very very important. It always starts with 0. So here's another thing I want you to know. So just put this as a separate table. So we have x minus 1, and we have the action. If the last bit of your x is 0 and your x minus 1 is 0, there's going to be no action. But if the last bit of your x is 0 and your x minus 1 is 1, what's going to happen? You're going to add x and y. And if your x is 1 and 0, and your x minus 1 is 0, you're going to subtract. And if it's 1, 1, you're going to do nothing. So please have this written down somewhere, because it's a very, very, very important concept. Let's go back to the problem. Remember I told you your x minus 1 always starts with 0. So now you're going to look at the last bit of x, and you see the last bit of x is 1. So what I usually like to do is like make a circle, because it just makes your work a whole lot easier. So you circle your 1 and your 0, and then you look at the table. You have a 1 and a 0, so what do? You subtract. So this is where your negative y comes into very good use, because sometimes you're going to be trying to subtract and it's going to be very hard for you. So why try subtracting when you can just add? I mean, addition is easier. So you just like use your 2's complement and say 0 1 0 1, and then you try adding. Adding, because we're subtracting, but we're going to be subtracting using the negative y. So you know that x plus minus y is the same thing as x minus y. So that's just the concept behind it. So this plus this is just saying x minus y. So when we add that, it's going to be 1 0 1 0, and that is what now we're going to use the right shift arithmetic. We're going to make a copy of the 0, and we're going to shift this to the right. So let's do this together. It's going to be 0 0 1. You see that goes here. 0. Now this I told you your u is 4 bits, so now the 4 bits is complete. So that's when you're going to shift over to the v. So it's going to be 1 0 0 0. It could have been 1 0 0 0 0, but because your v has to be 4 bit, you're going to have to let go of that last 0. You just have to let go of it, because you don't want your initial value to be a 4-bit number, and now you're going to have like 5 bits. So I mean, like, you have to like base your calculations of like your initial value, because your v is 4-bit. You have to continue using 4-bit throughout. So after doing this, you're now going to use your right shift circlet for your x. So that means this 1 has to come here. So if you do that, like I said, it's like a circle. It's going to be 1 1 1 0. Your x minus 1 is the same thing as saying what was the previous value of your x. Remember I said your x minus 1 which starts with 0. That's just the rule. It starts with 0. But now we're going to be changing it. Previous value of your x, this x you seen here, was 1. So that's what you're going to bring here. So that is going to be 1. So right now, like I said, we draw a circle again, and we go look up the table. And 0 and 1 you add. So now you're going to add y to this value. So if you want to add y, you don't add negative y, you're going to add y, because it says add. So you're going to add positive y. So that's going to be 1 0 1 1. So 0 plus 1 is 1, and 1 plus 1 is 1 0. So you have to put 0 here and put the 1 here. 1 plus 0 plus 0 is 1. 0 plus 1 is 1. So right now you're going to do the right shift arithmetic again. Going to try and shift this to the right. You're going to use the RSA down here. And like I said, make a copy of the first bit. It's going to be 1 1 1 0. This is 4 bits. Your U is complete. You take this 1 and shift it down here, 1, and you're going to continue like this, 1 0 0. So you're going to notice that the 0 is going to be cancelled, because you just need to obey your initial state, which was 0 0 0, which is 4 bits, and like I said, it has to be 4 bit. So if this was 5 bit, then that was going to stay, but because your V is 4 bit, these things have to be 4 bit. Now you're going to do the right shift circlet down here again, right shift circlet, and it's going to be 0 1 1 1. And like I said, your x minus 1 is the previous state. So what was your previous state of x? Yep, it was 0. So you're going to look at this again and ask yourself, what do I do? You look at the table, and the table says, first you circle it, my bad, circle it, then you look at the table, and the table says 1, your x is 1, your x minus 1 is 0. You look at the table, 1 0, you subtract. So now you're going to use negative y. So it's going to be 0 1 0 1, and then you are going to add it, and this is going to be 1 1 0, because 1 plus 1 is 0, and 1. So we all know that 1 plus 1 is 1 0. So we're going to put 0, and we're going to put 1 here. But I told you it's of U has to be 4 bits. So what is this 1 doing here? Because this 1 is here, it's disobeying the rule. So we have to cancel it, because it needs to be 4 bits. So anything more than 4 bits, it has to be cancelled. So if you have a remainder, you have to let go of the very first bit in this case. Sorry guys, I ran out of space, and I really want you guys to understand this concept, so I really have to emphasize it. Like I said, 1 1 1 0 plus 0 1 0 1 will be 1 1 0, and because this is 1 0 and it has to be 4 bits, you are going to cancel that out. It has to go. The next thing you're going to do is make the right shift arithmetic. So you're going to double the first bit, 0 0, and continue 0 1. Then this 1 comes here. Then it's going to be 1 1 0. So that makes it 4 bits. And you're going to do the right shift circlet for this bit, which is 1 0 1 1, and your last bit was 1. So looking at that table, so if we have a 1 and a 1, I told you there is no action. So here there's going to be no action. So what we're going to do right now, since there's no action, is make the right shift arithmetic. So you have to get this straight. If there's an action, either if you add or you subtract, you have to do it on the U. So that's why we have X and Y. So you have to add, either you add or you subtract, then you do the right shift arithmetic. Else, if there's no action, you just do the right shift arithmetic. So right now we have no action at all. So all you just need to do is the right shift arithmetic. And in order to do the right shift arithmetic, like I said, you just have to double the bits, which is going to be 0 0 0 0 0 1 1 1 1, and then you're going to do the right shift circlet for X. So if you want to do that, you will just bring the last bit and make it the first bit. So it's going to be 1 1 0 1. Do you see something interesting? This is the same as your initial state. And when that happens, you stop. Like I said, that's why we call it the right shift circulant. Because if you keep on doing this, 1 0 1 1 0 1, we're going to have 1 1 1 0 0 1 1 1 1 0 1 1 1 1 0 1. Eventually, it's going to make a circle and loop back to the initial state. So immediately that happens, you stop. 1 1 0 1 times 1 0 1 1. The answer in Booth's multiplication is 0 0 0 0 1 1 1 1. That, my friends, is your final answer. Thank you for watching this video, and in case you have more questions or you would like to see other videos, please let me know in the comment section below. Thank you very much.